We are live. Welcome, everybody. Deep dive with Vasily. Go ahead.
Yeah, welcome everyone. Today I'm going to talk about the topic called pull mirroring. So at GitLab, we support two types of mirroring. It's a pull mirroring when we fetch something from the remote repository into the GitLab repository, and the opposite process called push mirroring. It's when we push some new updates from the GitLab repository to remote repository. And I'm going to cover like what it is, how it's implemented like code-wise, what classes do we use, what kind of settings do we have, and I will also talk about the problems that we have with the current approach. So let me share my screen. So yeah, there is like, I created a deep dive issue with some of the notes. Feel free, I left like a link in our document, so you can also check that. And yeah, we have a documentation. If you're more interested about how the mirroring works, we have like a very precise like documentation, covers different parts, different settings, different like failures that users can have, like, or that might occur when you set up your pull or push mirroring. And let's take a look on this execution flow. I think it's like crucial to understand what kind of classes are involved, because unfortunately the implementation, it's not the simplest one, and it includes many like moving parts. So let's take a look on them. And by the way, if you have like any questions, feel free to raise your hand and I'll try to address them as soon as possible. So everything starts with a GitLab mirror, which is the class that defines the cron job. So we run the pull mirrors update process regularly. Every like 30 minutes, we start a new cron job that triggers update all mirrors worker class, which is responsible for detecting the projects that have outdated pull mirrors, and it creates batches of project update workers, jobs that gonna start the process of updating. The project update worker job is just to change the status of the import, the state of the import. So from the, it moves basically the project to the scheduled state. So we have like a state machine behind all of these changes. So we define multiple statuses for each step, and the project update worker basically does only that. It just moves it to the scheduled state, and later it's the pull mirrors with this state are picked up by repository update mirror worker, and they start the actual process of fetching new changes from the remote repository. So let's go step by step and explore all of these classes to see what's inside. So the first one is the GitLab mirror, which, as I said, defines a cron job. So it sets a cron job that calls the class update all mirrors worker. It provides some settings. For example, you can set the capacity. It's like how many simultaneous mirrors we are able to update. And these settings you can change, I believe, in the admin area. So you can modify it on the instance level. Like if you think that the process is too slow and like the update cannot catch up with all of the projects, then you can try to increase the capacity. So we'll try to process more projects at the same time. Yeah. However, it will be some like limitations at some point. So it will be like depending on your like network, on your instance, how powerful it is, and so on. So basically, it's what it does. It's a GitLab mirror. The next step is the update all mirror worker. And update all mirror worker, it creates the patches. If you take a look here, it creates a batch of the projects. So we filter out like archive projects, like deleted projects, and all of this stuff. And what's important is this next execution timestamp. It's basically a timestamp that we put on the project instance for us to remember when we should update the pull mirror next time. So we have right now a 30 minutes delay between consecutive updates. We do it like to prevent the situation when we just so we cannot update projects too fast because it requires much more like efforts and much more performance like to achieve that goal. So we have this like limitation. So after the pull mirror is updated, we update the next execution timestamp. So we put it like in the future. So this project won't be updated like in the next run, for example. So Ash, you have a question?
Yeah, so we can have multiple mirrors configured for a project, but we have one import state relation. How does that work?
That's a great question. And yes, we have multiple mirrors, but we might have multiple push mirrors, but only a single one pull mirror. And I will talk a lot about that a little bit later. The way how it's done, it prevents us to have, let's say, the import of the project and the pull mirror at the same time. Because as you mentioned, it's one field, and we reuse that field for many different processes. We use it for the import process, we use it for the pull mirror process, we use it when we create a project from the template. It's all the same procedure. We just like change the type. And because it's like it's attached to only single field, then we might have only one of these processes at the same time. So we might have maximum one pull mirror process. Hope it addresses your question.
Yeah, thank you. It's a tricky one. I think I brought it up just because I spotted it recently, and it is a little bit on the surface a little confusing, but it does make sense when you dig into the code. Thanks.
Yeah, but I think it would be nice like to remove this, and I'm gonna talk about that. It's like one of the problems that they see with the current approach, that we have this dependency and it affects the code quality and so on. But let's get back to where we stopped. So we have the update all mirror worker, which creates a batches. It detects the projects that needs to be updated. And after that, it creates the sidekick jobs for each project in batches. Then that's a job that it creates. It's a project import schedule worker, which verifies that the project exists. It checks if it has like a proper import state. And after that, it triggers the schedule event. And the schedule event, it changes the state of the state machine. And I'm going to show it to you where. So that's a state machine that we have. So we have initial state, we have started state, finished, scheduled. And when we schedule something from one of these states, we call add import job method on the project. Now let's go to it. Okay, should be add import job. Here we go. So the add import job, again, applies some validations, verifications, and after that, it triggers repository update mirror worker. And the repository update mirror worker actually starts doing the process of updating the mirror. So again, we get the project, we verify if it's still like a valid one, and after that, we trigger the start mirror. So we update the state from scheduled to started, and we run the update mirror service. And inside of it, we have the main logic. So here we verify if the import URL, it's basically a link to the remote project from where we need to fetch the new data. We check if the user has access, if we check if the project is actually a mirror. And after that, we execute project fetch mirror, which is the call to the Gitali. So we ask Gitali, hey, can you please fetch the data from the URL we provided? After that, we update branches because we need to, okay, let me see. Yeah, we need to synchronize basically the branches between the remote repository and our local repository. We update LFS objects if there's like any if there's any updates necessary. We also update tags, similar to branches. Here we go. Yes.
Sorry to jump in. There's
No
actually
problem.
a bug right there. Going back to the LFS objects, there's a bug that had to be rolled back. I just thought it was worth mentioning. And yeah, I think it's in the higher function where we try and determine if the LFS object should be synchronized, and there's a bug in the determination there, and a fix was rolled out to, I guess, try and accurately synchronize LFS objects all the time, and that actually ended up causing issues for other mirrors that didn't have LFS objects because there was lots of timeouts and things. So just thought I'd bring it up that it's a fairly very sensitive piece of code, and there's lots of it, as we're seeing. You're doing a great job, Vasily. There's lots of layers, but yeah, I just thought the LFS one was worth mentioning. There's a bug sitting right there that we need to address.
Emma?
Before Emma, Ash, is there an issue targeted at a milestone for that, or for that?
Yes, there's two.
Okay.
Yeah, there's one I'm working in indirectly, and then there's also an issue that's, I don't believe it's been scheduled for a milestone, but there's a few requests being made for it.
Okay. Can you either try to put it in a milestone, like tentatively, or just ping me and Devi on it so we can take a look at it? Either way. Thanks. Emma, go ahead.
Yeah, my question is very simple. What is LFS object?
So LFS, it's I think it's called large file system. It's an extension for the Git that allows you to, it's optimized for storing a large object. But basically, if you have like a files like 1 gigabyte of file, the Git is not really good like in dealing with all of this. It's kind of not, it's set mostly like for the smaller projects when you have, let's say, some code, when your regular files don't go like higher than like a few like kilobytes. But for very large projects, for very large files, it's better to use this LFS. It's like an extension that's more suited for in terms of the performance and in terms of the like availability for the bigger files. And that's we synchronize like separately. So we fetch basically the regular files, and after that we fetch LFS related files.
Right. But if we fail to update the LFS object, then do we stop the processing, or do we process it like asynchronously?
That's a great question. And actually, I think this part is what Ash was mentioning. I think we tried to uncomment it and it started tracing. So right now we don't stop the process. If LFS fails, we just like log this information. But we still continue like updating the repository. It might end up into this like inconsistent state, but it's how it is right now. And when we try to actually make like a hard failure for that case, so if the LFS cannot be updated, then it causes various problems. So that's something that we need to solve still.
Yeah, it's a good observation. There is a race condition. So if you have a lot of LFS objects that are very large, that outweigh the sort of size of the repository, maybe there's a megabyte or two of Git data, but terabytes of LFS storage, the Git data will be mirrored first, and we'll have a whole lot of disconnected object sort of links. And so there is, and that's the purpose of that commented that code there is essentially to work around that race condition. So yeah, it's a tricky one.
Right. Okay. Thank you very much.
And let's go back. So yeah, we do a few synchronizations like in this class, and that's mostly it. Ola.
Yeah, I was wondering, when we are updating branches, what's the precedence? And since we can pull and pull, can we have, like, for example, we are the primary and everything we see we mirror, or like when we see something overrides on our side, So I'm trying to understand like what the precedence is.
Okay, I got it. So we have a setting. Let me go here. I think it's about the override diverge branches. It's probably related to what you asked. So by default, if you have like a local branch that's modified in a different way how it's done on the remote, then we stop the process. So we say, okay, you have an error, you have some diverge branches. So we cannot really, because when we pull some information, then it might rewrite your current data. You can redefine this behavior if you click on the checkbox. It's override diverge branches checkbox. In this case, we'll proceed. So we're gonna override your local branches with the changes from the remote.
All right, thank you.
Okay, and let's talk a little bit about the problems that we have with the current approach. I think historically, the pull mirror was done on top of the import functionality, and it probably was easier to implement, and I see like similarities between these two processes, but we end up in many cases, we have this like ifs. If it's like an import, do that. If it's a mirror, do that. And that creates a lots of like friction inside of the code because it's not really like clear what's going on. And like I was jumping through like many classes here, but technically what we need to do, it's like two kind of main logical parts that we have. So first one, we need to find projects that need to be updated, and we need to schedule these projects to be updated. So it's basically like the update all mirror workers and the repository update mirror worker that like play the main part of that. And the rest is some kind of like integrations to make it work with the existing import functionality. So we build on top of this like state machine. So we reuse a state machine that the GitLab import uses as well. And that leads to like various problems, some like hidden bugs, because sometimes it goes in not in the right flow, tries to do the import and fails because of some like different types or some information is not available. So that's the first problem that we have. Another one also mentioned that we cannot do the import and the pull mirroring at the same time because we use the same fields, and it's like per project we have only one field called like import type. We have only one field called import URL, and that basically restricts us. We need to choose what you can do, either import or pull mirroring, but not both at the same time. And sometimes it gets stuck. I remember fixing one bug when after you imported the project, it was not possible to set up a pull mirroring for it because the import was populating these fields and the pull mirroring process was not able like to redefine them. So that was another problem. I think that probably my biggest concern about the current implementation is that the time that we require to process all of them, it grows like linear, like how many new projects we have, it takes longer to process the whole batch. So eventually, I don't know when it happens, but might eventually happen that we'll have so many projects that needs to be updated. So the process of updating all of these projects will go over this like 30 minutes delay. So it means from the customer perspective, my project won't be updated every 30 minutes, but we will be every 35 minutes. More projects we have, it will be every 40 minutes and so on and so forth. And that's something that we would like try to avoid. There is APAC. It's called Pull Mirroring version 2 that describes a different approach. We probably can talk about that like next time because it's quite much of the information. And yes, Ash.
Thank you for linking that. I've just followed. I wasn't aware. It's great that we have some discussion around how it could improve. I hope there's something in there around improving the visibility. So from the user perspective, I'm sure you've discovered this facility. There's not a huge amount of information given to the user about the state of the sync in terms of when it's next scheduled to run, how much it's progressed. You really get a state of it is last successful at some particular stage. and some very kind of difficult to understand error messages. So I think that's another big challenge too. I think that's indicative of the code complexity. But yeah, it'd be great to see that improve, because that's a really common sort of customer question around improving that.
Yeah, makes total sense. I don't recall if we have an issue for that. Yeah, if not, I think I'll create one, because yeah, it's an important topic. I think the current implementation, we only show like if there is an error, and we just like provide the error that we get from the like Git operation, and sometimes it might be like cryptic for the customer, so it's not really clear. And we have some of the like definitions, I believe, in the troubleshooting section, like what to do if you like get this type of error, fetch remote, Fettel cannot read username, blah blah, and so yeah, that can be definitely improved. And I think I have the last part. It's relatively small, but anyway, we have this discrepancy. So we have an API for push mirrors. Like it's like a separate state of a separate set of the endpoints. And it's done like better than the pull mirroring, because the pull mirroring is integrated inside of the project. So to configure the pull mirroring, you make a request to the project like entity, and you update some fields on that, instead of having like API project ID / pull mirror, and then you can modify the pull mirror itself. So yeah, that's mostly like, I think this part might be confusing also, because in order to configure the pull mirrors, you need to go to the project's API, and you need to know that you can find it here. Yes, and I think that's mostly it. Yeah. Thank you for your attention. If you have any questions, you can still
Thank you, Vasily.
welcome.
It's really fun to see something you keep hearing about so often, but like seeing the belly of the beast, like how it's working and operating, it's really just code. It's tunnels all the way down. Thanks, Vasily, for showing us. Anybody has questions? If you don't have now, you have later. You can always ping Vasily on Slack and pick his brain. All right, I'll make sure that the video is made available. I don't think there's any harm making it public, right, Vasily?
I don't think so. I think it's all good.
Right, I'll make it public right after this and drop it on Slack. Thank you so much, Vasily, for doing that, and thanks everybody for your time. And sorry for going a little bit over time, but it was definitely interesting, so worth it. Cool. All right, see you all around on another call.